Here's the equation of an exercise on the applications of first-order differential equations found in the book Advanced Engineering Mathematics by C. Ray Wiley and Lewis C. Barrett. From page 61, number 85, determine how an initially charged capacitor will discharge through a resistance, i.e. in the succeeding exercise. Find Q if there is no voltage source in the circuit and the charge on the capacitor is initially some non-zero value Q0. When a capacitor of capacitance C is being charged through a resistance R by a battery which supplies a constant voltage E, the instantaneous charge Q on the capacitor satisfies the differential equation R dQ over dt plus Q over C equals E. Find Q as a function of time if the capacitor is initially uncharged, i.e. if Q0 equals 0. How long will it be before the charge on the capacitor is 1/2 its final value? Given the differential equation, R dQ over dt plus Q over C equals E. Reducing the equation to its standard form, we have dQ over dt plus 1 over RC times Q equals E over R. Now, we find the integrating factor V, and V is equal to E to the integral of 1 over RC dt. Integrating the exponent, we have V equals E to the T over RC. Then, dt times the dependent variable Q times the integrating factor E to the T over RC is equal to E over R times E to the T over RC dt. Integrating the obtained equation, we get Q times E to the T over RC equals E over R times the integral of E to the T over RC dt. Working on the right hand side, we let U equals T over RC and du is equal to RC dt over RC squared. So, dt is equal to RC du. From this equation, we obtain Q times E to the T over RC equals EC times E to the T over RC plus C. Simplifying, we now have Q of T is equal to EC plus C times E to the negative T over RC. Now, to find C, we let T equals 0. So, Q of 0 is equal to EC plus C E to the negative 0 over RC. Then, Q0 is equal to EC plus C, and C is equal to Q0 minus EC. Now we have the value of Q at any time t using the equation Q of t equals EC plus quantity Q0 minus EC times E to the negative T over RC. But since E should be 0 and the change in the capacitor is Q0, by substituting these values, the equation becomes Q is equal to 0 plus Q0 minus 0 times E to the negative T over RC. And finally, Q is equal to Q0 times E to the negative T over RC.